Hello, and welcome to Math with Mr. Bill. I'm Bill Anderson. Today we're going to be looking at approximating an integral using rectangles of a particular width. So we're asked here to approximate the integral from 1 to 3 of x plus 1 over x using two subintervals of equal length and the right-hand endpoints of those intervals. So the best thing to do with something like this is draw it out. And the graph doesn't have to be perfect, but it will enable us to find the answer way more easily than trying to figure out using some kind of formula or some kind of algorithm. So we've got points here. We'll put one right there, and then one right there. There's 2 and 3. If I put 1 into my equation, we get 1 plus 1, which is 2. And let's put that up. Let's put that right here. There we go. Call that 2. Plug in 2, we get 2 plus 1/2. So that's 2 1/2. And we plug in 3, we get 3 plus 1/3, which is 3 1/3. Okay. So we have kind of a gently sloping upwards point right there. Okay, so now we need to draw rectangles on this curve, and we're going to be using the right endpoint for each interval. And we're going to be separating this into two subintervals. So the natural subintervals here are from 1 to 2 and from 2 to 3. And the height of my rectangle is going to be taken from the right endpoint of each subinterval. So from 1 to 2, I'm going to be using 2 to give me my height. And then from 2 to 3, I'll be using 3 to give me my height. So when I draw out those rectangles now, you'll see that part of the rectangle is above the curve. And so when we find our area, we're actually going to get an overestimate. And something good to know, especially if that's relevant for any questions that you're being asked. Okay, so now we need to find the area of each of those rectangles. So we've got f of x is equal to x plus 1 over x. We have the width of each of our rectangles, which is going to be 1. And so our height now, the first height we want is the height at 2. So f of 2 is equal to 2 plus 1/2. So that's 2 1/2 or 5/2. And then for our second rectangle, we want the height at 3. So f of 3 is equal to 3 plus 1/3, which is 9/3 plus 1/3, which is 10/3. So then the area of each rectangle happens to be just the height because the length of the rectangle is 1. So the area of the first rectangle is equal to 5/2, and the area of the second rectangle is equal to 10/3. So then the total area is just the sum of those two. And so that's going to be equal to 5/2 plus 10/3. And we get a common denominator of 6. So that is going to be 15/6 plus 26/6, not 26/6, 26/6, which is 35/6. And that's it. That is your approximation. That's an overestimate for this integral, but it's at most 35/6. So if you have any questions, feel free to put them in the comments below. If you have any other problems you'd like me to do, please feel free to put them down there as well. Otherwise, thanks for watching, and I'll see you on the next problem.